Tangent is also defined as being the sine of your angle over the cosine of your angle, not sine over cosine followed by your angle. Similarly, cotangent, which is a reciprocal tangent, has to be the cosine of your angle over the sine of your angle. We then have some different definitions for sine, cosine, and tangent, our trig functions. It says we have any point on our circle, or on our coordinate plane, which we'll put over here. X units over, Y units up. You can then go ahead from there and draw a right triangle down to your x-axis. When you have your point, and you're always drawing your right triangle, you always draw it to the x-axis, never to the y. You then draw a line coming from the origin out to your point. That's your hypotenuse, which we refer to as r. Your angle is always the acute angle in your triangle at the origin. Well, using your distance formula or the Pythagorean theorem, you would know x squared plus y squared would be equal to r squared. So when you solve it for r, you get r to be the square root of x squared plus y squared. Now, if you did want to go ahead and think of SOHCAHTOA, you have sine was y over r. Well, that should make sense because if you're thinking in SOHCAHTOA, the sine of your angle would be the opposite, which is y, over your hypotenuse, which is r. Similarly, when you're looking at your cosine, cosine of your angle would be adjacent, which is x, over your hypotenuse, which is r, which is given to you here. Then you have tangent. Tangent of your angle is your opposite, which is y, over your adjacent, which is x, which is given to you here. Then you, of course, have the reciprocal function, so you're just flipping these upside down. Now, you might be wondering why we have some of this stuff afterwards, if x cannot be equal to 0, or y cannot be equal to 0. Well, that's because we have x and y being on the bottom of these, and we can never divide by 0. Now, why don't we have to worry about that with these two here? Well, it says that your point is any other point than the origin. So that means this distance here will never be 0 because your point can't be here. It has to be some other point. Therefore, the distance between them will be a positive number. Your domain for sine, cosine, and tangent is all real numbers, because you never had any problems back here with issues of dividing by 0. However, when you look at your tangent and your secant, we have issues when the bottom is 0, when x is 0. Well, when is x 0 here? Well, x would be 0 if you were right up here or right below down here. So that would be a 90-degree angle or a 270-degree angle. So our tangent and secant are defined for all real numbers, except we can't be 90 plus a half a revolution beyond that, which would be at your bottom of the 270, then back at the top again, and then you keep going a half a revolution beyond that. If you're dealing with radians, it would be pi over 2 plus pi n. When you look back over here again, for your cotangent and your cosecant, they both have y in the bottom. Where is your y equal to 0? Your y is equal to 0 when you're going straight to the right, or a half a revolution going straight to the left, or another half a revolution going straight to the right. So it ends up being all real numbers, except your angle cannot be equal to any multiple of pi, because you're dealing with can't be 0, can't be pi, can't be 2 pi, can't be 3 pi. Well, that's just multiples of pi. Or if you're dealing with degrees, it would be multiples of 180. We now want to go ahead and find x and y based on this. Well, if we want to go ahead and find x first, here we have our angle. We're trying to find this, and we know this. Well, Here's your angle 60. This is your opposite. That's your hypotenuse. So I'm going to go ahead and use sine. Sine of 60 is equal to the opposite of that, which is 3, over your hypotenuse, which is x. Sine of 60, from which you're supposed to have memorized, but probably haven't done so yet, is root 3 over 2. So I'm going to replace the left side with root 3 over 2, equals the right side. All we have to do is just cross multiply and solve it for x. When you finish solving it for x, showing all your work, you'd end up getting 2 root 3. And you'll end up having to also rationalize your denominator when you're showing your work on that one. Now, we have this side here, and we're trying to find y. Well, that would be opposite and adjacent. So I'm going to go ahead and use tangent. Tangent of 60 degrees is equal to the 3 over the y. Tangent of 60, from what you're supposed to have memorized, is a root 3, which is really a fraction over a fraction. So then you can go ahead and cross multiply. Finish solving it for y. You get 3 over root 3. Then you want to rationalize it, and it simplifies down to just a root 3. We now want to go ahead and find our 6 trigonometric functions for the cosine of 8/17. Well, our 6 trigonometric functions are listed below here. Here's your 8/17 for cosine. So it should be pretty easy to do your secant because secant's the reciprocal of that. But we still have to figure out the other 3. Other 3, I can't count. Other 4. So, you know that cosine is adjacent over hypotenuse. So let's go ahead and draw ourselves a right triangle. We'll put an angle down here, theta. Adjacent to your angle has to be the 8. Your hypotenuse then has to be the 17, since cosine is adjacent over hypotenuse. So this is 8, that is 17. All we have to do now to figure out the missing side is use your Pythagorean Theorem. This side squared plus this side squared equals that squared. Subtract your 8 squared, which is 64, from both sides. Take your square root, and you end up getting 15. So this vertical side, as the triangle is drawn, is 15. You now want to go and do the sine. Opposite of 15 over adjacent of 17. Do your tangent. Opposite of 15 over your adjacent of 8. Well, the other two are just the reciprocals. Cotangent's the reciprocal of your tangent, so you got to flip that upside down. Cosecant's the reciprocal of your sine, so you got to flip that upside down. We want to go ahead and approximate these with our calculator, which means all you're going to do is turn your calculator on. Since we're dealing with degrees, you want to make sure your calculator is in the degree mode. Then just go cosine 77 degrees, and it should give you a decimal approximation of this. For the most part, we'll go 4 decimal places. Over here, we have secant of 202 degrees. Your calculator does not have a secant button. But remember, secant is the reciprocal of cosine. So write out 1 over cosine of 202 degrees. Now that's what you're going to want to type in. Over here you have cotangent. Your calculator does not have cotangent, but it does have a tangent. Remember that cotangent is the reciprocal of tangent. So you do the reciprocal of tangent, 1 over tangent of your 81 degrees, and that's what it is you need to go ahead and type in.